On this episode, we look at pedestrian problems in Thorndale, Pennsylvania. Then we head east to Philadelphia for the annual conference of the American Institute of Architects. We talk about pedestrians with a traffic engineer from the city. A company in Maryland makes pedestrian crash test dummies. The National Youth Bike Summit meets in Washington, D.C. A rail commuter enjoys her walk home from the Harpers Ferry station. And finally, a school does more to protect its buildings than its students. Stay tuned. We're in Thorndale, Pennsylvania, talking with Barry Rabin. We're standing next to Lincoln Highway. What's the problem with Lincoln Highway here?
Well, Lincoln Highway is a great place to drive your car or truck down, but unfortunately there are no sidewalks here, John. What that means is if somebody wants to go down the street to buy something, go to the store, get a snack, get a cup of coffee, etc., they almost have to drive, or else they're kind of ostracized and forced to walk down the gutter, as it were, down here. I've talked to the local officials numerous times about this and told them I thought they should start requiring sidewalks, at least when new construction comes in or when the road gets redone, which is scheduled to happen soon. And unfortunately, they don't seem to have a lot of enthusiasm, or at least they don't seem to see the importance of having sidewalks put in here, what it would do to enhance the quality of life here in Thorndale.
Other than sidewalks, which would be nice to have, what else could be done that would improve the street?
Well, they could certainly put some trees in and beautify it a bit. I mean, even the outgoing township manager referred to this stretch of road as ugly. I think that was his exact description. This could look like a town. It's certainly congested enough. It's got enough businesses and homes to be a town, but there are no trees, very few trees anyway, and no sidewalks, no strip of grass, no flowers. It just really detracts from the quality of life here for those of us who live here and work here.
What impact does that have on community?
Well, I think the impact it has is you don't feel like there is a community. You really don't, other than, those people that are in maybe a couple of the organizations where you go once a week and you meet. You just don't get to know people. And when you know people, you don't run into them on the street because they're all driving. You might beep your horn at them if you recognize their sport utility vehicle or their car. But, I used to work in an old town where you'd walk down the street at lunchtime and you'd see your friends and you'd chat with them. And the incidental contacts that you have with people day to day that really make it a nice place to be. You just don't find that here because of the lack of sidewalks and the lack of landscaping with them. The people here are great, very nice people here, but the structure of this place is such that it is just not conducive toward a community feeling.
We're in Philadelphia talking with Stephanie Bothwell, who's director of the Center for Livable Communities with the American Institute of Architects. What is the center?
Well, the center sits at the AIA in Washington, D.C. It's a national center. The AIA is about 63,000, some say almost 65,000 members now, architects from all over the country and other associate members. And the center was formed about a year and a half ago to begin to address the issue of livability and the role that architects and design play in that issue.
You have your big annual conference here in Philadelphia this week. And what is the theme of this year's conference?
Livable communities, which we're very happy to say, and we'll be building this year towards next year's convention, which will be in Denver.
What are people talking about? What does it mean when you say livable communities?
It's interesting because for everyone, one of the things we decided that there were some basic rules of the road if we were going to take this issue on. We realized that one size does not fit all, that we really need to look at principles of great design that we've worked on and grown up with and grown as a civilization with for hundreds of years, great principles rather than formulas of how to create community. and that every region, every area has its own culture, climate, and environment, those principles need to be interpreted into. So as we look at the issues for each community, they take it on differently depending on what their issues, what they have in front of them, whether they're starting in an existing center city, in a rural circumstances, or in a suburban setting. How to increase the quality of life there using good principles of design and planning.
And sometimes people talk about walkable communities. How would that fit in with the idea of livable communities?
Well, I think walkability is a great indicator. When people feel that they can make choices about what it is that they want to do, services that they can have access to, opportunities at different ages, whether it's children, mothers at home with kids in strollers, or kids going to school, or the elderly, that people in all walks of life and in all ages, and without regard to income level, have access to the street, public space, access to mixed-use community, so that they can walk to, let's say they might be working at home all day on the computer, but they can take a break, walk with the children down to a local coffee shop, or pick up some bakery goods or whatever's they're going to cook for dinner, and bring that on back home. And in that activity, they're actually out and about, seeing other people, seeing what's going on in the community. And I think it makes people much more aware and much more sensitive to their environment, and not so inclined to let inappropriate behavior or inappropriate activities occur because they can provide oversight in the street, because they have a decent place to walk, a sidewalk, and they're out and about in the community.
We're in Philadelphia talking with Guy and Jordan, who's a district traffic engineer at the city. What else do you do when you aren't busy working for the city?
Well, I do a lot of research on pedestrian and bicycle and disabled transportation facilities. I'm a member of the TRB Pedestrian Committee in Washington. I sit on the State Bike Ped Committee in the capital of Pennsylvania, Harrisburg, and I'm on the Mayor's Commission for People with Disabilities. Philadelphia is a very pro-disabled town.
And so I had a chance to learn a bit about what pedestrians need, what's good for pedestrians. What is it about Philadelphia that makes it good for pedestrians?
Philadelphia is an old city, and we inherited excellent, innately pedestrian land use because the vast majority of the city was built prior to the automobile. And so we understand the economics of the pedestrian and the livability of pedestrians. And so we do what we can to help pedestrians in this town. We realize that the Liberty Bell is not a drive-through attraction. So when the streets are very narrow, it's easier to get across them. Speeds are lower. We have a lot of one-way streets. There's less conflicts at intersections, safer for the pedestrians. Much of that is just innate. The engineering department also puts a good deal of time and energy and thought into how we can make things safer for pedestrians. You always see signals for pedestrians, even if it's a one-way street and you're going against the one-way. Our intersections have lots of continental crosswalks, stop bars, etc. Sometimes we're making stop bar setbacks, making the crosswalks wider. We have a good deal of pavement markings that we're putting down to try to make cars not park in the corner clearances so that cars don't bump into each other because they can see each other on our narrow streets. We have curb ramps almost everywhere. We have done some research on audible traffic signals, which will not evolve into the national standards because they talk. And they just said, well, the signal's green to cross Broad Street. And because it's in English, it will not become a standard because we're going to symbology and signs the same way in voices.
So you benefit from this 100-year-old or many hundreds-year-old tradition of narrow streets and a pedestrian orientation. How are you going to build on that in the future? What can we look forward to 100 years from now in Philadelphia?
Well, we're putting in more bulb outs when we reconstruct streets. You saw some today that we, at the intersections, bump out or bulb out or extend the sidewalk. This lets the pedestrians see what's coming up and down the street while being on the sidewalk. When you have large traffic flows, such as in Center City, you can see the office buildings, that when pedestrians are going one direction, the people crossing the street aren't in their way, so you have more capacity for the pedestrian. And it lowers the distance the pedestrians at risk when they cross the street, particularly good for the elderly. We have a high elderly population in Pennsylvania, only behind Florida in percentage of older people. And it's good for short people and children because the cars can see them if it's at a stop sign intersection. One of the other things we've been doing is we've been removing traffic signals with terrific success. I think in the last 10 or 15 years we've pulled out about 500 signals, and in virtually every case crashes drop by half, because when people see a traffic signal they have a tendency to speed up and they're looking up at the light, their foot's on the accelerator, boom, I'm going through the signal. And then people teach children, wait for the green, as soon as it's green they take off like the Flash. They're kids, they're impatient, and they take right off into a car still running the signal, high speed crash, injury, severe injury. Whereas if you take that out at a low to moderate volume intersection, now everybody has to slow down for their own self-protection. So the automobile drivers, instead of speeding up through the intersection, go into the intersection with their foot on the brake, scanning. It's not perfect. They slide through. They may not come to a complete stop, but at least they've slowed down. Their foot is on the brake. The reaction time's much better, and they're looking. They may not always yield, but there's a difference between injury and politeness, I guess. And we've been very successful with that program. We have extensive school crossing guard program, and there's hopes to better educate the school crossing guards in the near future. And that's a well-respected institution here in Philadelphia. I think that's good. Philadelphia has taken some federal enhancement money and is going to have the largest Teach Children to Ride Their Bicycle Safely in the Schools bicycle education and something program. And this will be the largest one of its type in the United States. So we're looking forward to coupling that up with our new bike lanes and bike racks and some outreach we've done, a very nice video, to try to make it more welcoming for people to ride their bicycles in town so they don't always have to drive or take the subway or whatever.
We're in Boonesboro, Maryland, talking with Mr. Rangarajan, who's the founder of GSAC. What is GSAC?
It's a general engineering and systems analysis company, and we specialize in research in biomechanics, now in crash test dummy design and building, and we do general design and building also. We are a manufacturing company also.
Crash test dummy, you don't just take a store mannequin and draw some paint on it. What's involved in designing and building one?
Typically a crash test dummy should look like a human being and behave dynamically like a human being. For instance, a pedestrian dummy should behave dynamically like a human being when it is hit by a car. So that's why we use dummies, because we can't use human beings to design cars, to design better cars. We use dummies. So the way we design dummies is we get data from, say, cadaver tests, and then what we do is we measure a lot of things in the cadaver, which is hit by this car, for a test. And then what we do is we get data from that, and we have a lot of anthropometric data about human beings. So we say, well, this is going to be like a 50th percentile male. So there is some height and weight and body segment sizes that are associated with that 50th percentile male or a 5th percentile female. That is our starting point. Then we know, for instance, how the dummy moved, how does the chest crush when you load it. We have all that information. Then having all these performance requirements, we then translate it into a mechanical system which will give you the same kind of response And the next part to building a dummy is putting enough sensors into the dummy, because it's no use smacking a dummy and not getting any information. We really want to know what happens to the human being. For instance, how does a head accelerate or decelerate when it hits the bonnet? You want to know what happens to the pelvis when it is hit by the front of the car. Because there are some data which relate the kinds of loads to kinds of injuries people get. So you do want to measure the dummy to be able to measure all these things when you hit it with a car. So the next thing we do is we build all these sensors into the dummy. And in the pedestrian dummy, it's a special case because it has a lot of sensors. So it may have like 100 channels of data coming off of it. And therefore, there'll be a big umbilical cord that will convey all the information from the sensors to the ground, to the laboratory. And it may be so big that the dummy won't move properly. So what we did was, in this dummy, we designed a data acquisition system that fits within the dummy. So all the sensors will put out information to these data acquisition systems, which will acquire the data during the test and store it. And at the end of the test, you go and plug in your PC and take all the information out of the data acquisition boxes, and then you can analyze what happened to the dummy, what kinds of injury potential is there in each design of car. That's how you build a dummy.
You talked about the pedestrian dummy, which I guess this is relatively new that you're actually doing a pedestrian dummy. What's been the history of testing for pedestrians as opposed to vehicle occupants, which is what we always see with Vince and Larry?
Sure. I think there has been a lot of interest in the United States also, but I think there has been much more interest in Europe and Japan, where they have, I think percentage-wise, they have probably a higher percentage of fatalities from pedestrians. And a lot of work has been done in the past on trying to design cars which are safer for pedestrians. Some of the problems that people faced were, first, there was not much cadaver data which predicted what will happen to people. So it's hard to design a car when you don't know how to design it, what hurts people. You just have some guesses about it. And secondly, when people tried to simulate pedestrians with dummies, existing dummies, and hit them with cars or on sleds, they had several problems. The chief one was that dummies were not robust enough, which meant that dummies break down after a couple of tests. And apart from the time problem, that you have to rebuild the dummy, recalibrate it, if one uses a newly recalibrated dummy, which is going to be subtly different from the last one, then one never knows for sure if you see a change in the behavior of the dummy. Was it brought about by the change in the design of the car, or because the dummy behaved subtly differently in calibration? So these are the main problems. And it is very hard also to think of a test configuration. You can imagine when you hit a person with a car, person flies all over the place. So does the dummy. So it is hard to contain the dummy and to devise a test method that will consistently, which you can reproduce. Because one of the things one must be able to do with any test is it should be standardized in such a way that if you hit the same dummy with the same car, with the same speed and everything the same, it should go the same way each time, or within reason. And many times it is very difficult to devise a test method which will do that for you with a whole dummy. So what they did, I think, in Europe was they decided that it is easier to test with parts of the dummy. For instance, they decided, okay, instead of testing with the whole dummy to see what happens to the leg, we'll just test with the leg of the dummy. So they created several versions of legs of dummies, which was sort of instrumented, and they would then fling them at the car at velocities up to 40 kilometers per hour, and the instrumentation on the leg will measure what is happening to the leg. Then they will try to guess at what kinds of injuries could have been caused. Personally, I think it's a very nice system if you already have a car that is designed and you want to evaluate its injury potential. But I think if I want to design a car from scratch, if I just test it at the leg, then I don't know what happened to the head. I mean, I may make significant improvements as far as injury potential to the leg is concerned, but I may be causing more harm to the head, for instance. So my viewpoint is, and I'm not an expert in this, but my viewpoint is that one should really test somewhere, after in the process of developing a car with a whole dummy, because that gives a whole picture as to which part of the dummy gets injured. It may not be the legs, it may be the head. So we need a whole dummy to test the whole car is the way I think about this.
You just completed a pedestrian dummy, shipped it off to Japan yesterday.
Yes.
How's that going to be used? What happens in Japan now?
They're going to actually test it. Our customer is going to test it. I think they're going to drive a car into the dummy and they're going to stand up the dummy. Traditionally, we have tested this dummy several times before, at least 5 times. It's undergone about 60 tests, I think, now. Traditionally, the way we test it is we take the car body, mount it on a sled, and accelerate the sled till it gets to the right speed at which we want to make contact with the dummy, and have the dummy standing right there, on the track, and then the car will then hit the dummy, and the car will start decelerating as though I hit my brakes, when I hit somebody. But now this time, they are not going to put it on a sled. They are actually going to drive a car, tow a car, and then hit the dummy with that car. So that's what they are planning to do this year.
We're in Washington, D.C., talking with Barrett Venkat, who's on the National Youth Advisory Board of Earth Force. What is Earth Force?
Earth Force is really youth all over the nation making lasting changes in their community to make the world a better place.
And what role does the Youth Advisory Board play in that?
Youth Advisory Board is like the main motivation behind Earth Force and behind our entire ideal, because Earth Force is youth, so the Youth Advisory Board creates our programs, implements the programs, and makes sure that they launch and they work perfectly. So we're right behind it all the way.
What are you doing in Washington this week?
Well, we all came in about a week ago, and we had meetings, and then last night and today we're here to recognize the winners of our Get Outspoken campaign. And Get Outspoken is a way for youth to, in their communities, help make them more bike-friendly. And by bike-friendly, I mean having bike racks or bike paths. So that way, instead of driving a car, you can ride a bike and save on air pollution, make people healthier, and just overall, it's better for the community.
So the Get Outspoken campaign, how does that work? How would someone that heard about it create do you have chapters, or how does it work in the local communities?
Well, what you do is you can request the materials from the national office in Washington, D.C. And what you do is the materials are very self-explanatory, and it's modeled for each individual community. So you just first you have to assess your community and see what kind of problems you have and what kind of assets you have. And if you realize that there aren't enough bike paths, what you need to do is you need to start talking to representatives, talking to your mayor, talking to your Department of Transportation, and try to convince them to help build bike paths, help put in bike racks. And it's a lot of it's not, and the action, it's not only action that just you do it one day and it's done, it's action that lasts forever. It's not for your lifetime, but for the lifetime after that, and for every child who will be in America after this.
And you had some awards given out today. What were the award-winning projects? What had people done?
Well, we had 3 award winners from New Jersey, Pennsylvania, Florida, I believe. And these winners, what they've been doing in the communities is they've been implementing this Get Outspoken campaign. They've been doing things like building bike paths, getting the support of the different community members, getting the support of Congress people, and they've worked to inform the public about bike safety, bike education, I think the main thing is awareness. They've been working to create awareness in their communities, and that's the really important thing.
We're in Harpers Ferry, West Virginia, talking with Christy Huddle. You just got off the commuter train from Rockville with a whole bunch of other people. You saw a lot of people driving off in their cars, racing to get out of the parking lot. How are you going to get home?
Oh, I walk home. And usually I try to get off the train first, so I beat all those crazy people across the parking lot.
And is it an accident that you just happen to live walking distance to the train station?
No. I used to live in downtown Rockville, about 250 feet from my office, and then when I decided I wanted to buy a house, I couldn't afford Montgomery County, so I just drove out the train line. I can't commute by car. I learned that earlier in my life. And when I got to Harpers Ferry, I said, this is where I want to live. And saw a real estate sign, called up the realtor, told him I was looking for a house within walking distance of the train station, and to me that was 1 mile, no more than 1 mile. And came out a week later, had an appointment with him, and he had 3 houses for me to look at, and 2 weren't even close to being within a mile. And I looked at the 3rd house, and we drove the distance, and it was exactly 1 mile. And I liked the house and went to the planning office, went to the mapping office, and found out that everything was what I wanted, and I bought the house that day.
Now, what are the benefits of walking? And why do you like to walk to the train?
Well, here the benefits are it's a very healthy walk. I mean, the air is relatively clean. It's gorgeous scenery. I like it wakes me up in the morning. I can then sleep on the train. Again, I walk at the other end too, in Rockville, about a 1/4 mile. I sleep better at night. It takes away the stress. I stay slim and trim, and I love it. I love it.
We're on Wilson Lane in Bethesda, Maryland, in front of the Thomas Pyle Middle School. They have some temporary classrooms set up on the front lawn here to take care of the huge crush of students they have. They have jersey barriers set up along the edge of the sidewalk, presumably to protect the classrooms from out-of-control vehicles. The problem is, they squeeze down the sidewalk space. If you have a group of students walking home together, they aren't going to fit on a 4-foot sidewalk. They're going to spill out. If it weren't for the jersey barrier, they could spill out onto the lawn. But since that's not an option, they'll spill out into the street. Not the sort of situation you want to create. There were other choices for the jersey barriers. They could have put them over on the curb and protected the pedestrians as well as the buildings, or they could have set them back a few feet and left the students that extra space to spill out onto the grass. Apparently, that never occurred to them.
Visit us on the internet at www.pedestrians.org.